Hello, everyone. Just wait a second here for all the attendees to file in now that the webinar is nice and open here. We'll go ahead and kick it off with some introductions from Rob and I, but a couple just kind of logistical pieces here first. First of all, there will be a CPE given out for this webinar. In order to get that CPE, you have to answer at least 3 of the 4 poll questions that will be coming. So please keep that in mind. I know Casey will put that in the chat as well, along with the other instructions that you need to kind of cash in on that CPE after the fact. And as far as what we're covering today, we'll be talking about a few major breaches specifically related to the trends that we've seen in supply chain attacks and some of the DevSecOps lessons that we've taken away over the last 6 or so months from these major breaches and how your teams can address those moving forward. So with that, let's go ahead and dive into introductions here. Rob, I'll let you go first.
Sure, I'm Rob Patrick. I'm with CyberArk. I am make sure I'm not muted here, making Zoom mistake number 1. So I'm a DevSecOps specialist with CyberArk. My background is I spent the first decade or so of my career actually doing software development, and then worked for a myriad of DevSecOps tool vendors, helping others do DevSecOps better, and then finally came to CyberArk, where I'm a specialist helping customers do more of the sec of DevSecOps.
Perfect. Yep, and we'll talk about the CyberArk platform in a bit more detail towards the end, and kind of how Rob fits into that whole product development and everything the team's doing over there to make this whole idea more accessible for folks. As for me, my name is Kyle McNulty. I'm a senior manager at Focal Point. I head our cloud security and DevSecOps practices, so obviously relevant as we talk here today. Previously worked at KPMG for several years and have experience across a wide variety of different security domains at this point, a bit of development background as well. So it ties in nicely to everything we're talking about, and I understand the challenges from both the security and the development side as we talk about some DevSecOps, just kind of cultural shifts that are required here. So with that, let's go ahead and jump in. We're going to kick this off by talking about 3 specific breaches, and then we'll address SolarWinds, which is number 3, in a bit more detail, and we'll dive into some common themes and go from there. So breach number 1, CodeCov. Again, I'd imagine a good number of you have heard about these 3 breaches at this point, all extremely significant impact based on the supply chain structure. What happened, basically, CodeCov is a DevSecOps code coverage and testing tool. There was a vulnerability within the tool which allowed for the compromise of CodeCov customers. And so already, as we think about this is a tool that's designed for DevOps, and all of a sudden there's security issues for all their customers, significant brand impact for them. What happened? We won't dive too much into the technical details, but basically there was an issue with their bash uploaders, and the attackers were able to exfiltrate sensitive information from those customer environments, such as path variables, which might include usernames, security credentials, such as passwords or API keys, tokens, and again, was able to access the environment of those various customers. 29,000 enterprise clients. As of this deck being put together, there were hundreds of customers that were said to be impacted. That's one of the kind of tricky pieces about these supply chain attacks is it's very difficult to actually establish just the full scope of the impact of these attacks. Not every organization that is potentially impacted actually realizes that impact, and not all of them kind of discover whether or not they've been breached yet as well. And that segues nicely into the next one here, which is Excellion. And so just kind of jumping ahead of myself briefly, one of the interesting pieces about this is it's been over 6 months now since the attack was actually disclosed, but just Morgan Stanley earlier last month disclosed that they were breached by this attack as well. So again, 6 months after the disclosure, after the patch, and organizations are still feeling the impact of this breach. So again, what happened? Well, sensitive information from education institutions in particular, at the kind of beginning of the attack disclosure, that information was found on the dark web. So we have several kind of high profile educational institutions listed there: University of California, Miami, Colorado. and all were confirmed to be Accellion customers. Ultimately, their FTA, their file transfer appliance, had 2 0-day exploits. You can see the timeline there, December and January. Those exploits were leveraged to gain access to the organizations, the Accellion customers. And one of the kind of key downsides of the Accellion FTA platform and the location of the vulnerabilities is all this sensitive information was stored on those file transfer systems. So as soon as the attackers were able to access those file transfer systems, they also had access to some of the most sensitive data that organization wanted to prevent being disclosed. So again, as we can see here, the impact is still kind of largely undetermined. We're still seeing new customers disclosing their breaches today. More than 3,000 organizations are customers of that specific Accellion product, and it's continuing to grow. So now I'll turn this one over to Rob here, but everyone's favorite or least favorite breach over the last year or so, depending on how you look at it, SolarWinds. So take it away, Rob.
Yeah, sure thing. And just before we jump into that, just to me, a couple of interesting things about CodeCov and Accellion. Number one, CodeCov, everybody focuses on the effect of it with all the 29,000 potentially impacted organizations. But to me, it all boiled down to a secret in a container, a Docker file, Docker image rather, had a password or a certificate or something in there that shouldn't have been in there, and somebody was able to find it and exploit it. So it's something as simple as that. And Accellion, the interesting thing there to me is that was a 20-year-old software package. You know, that wasn't something that was new. So you can't just assume, since it's been around the block a few dozen decades, that something is not that it's totally secure. So anyway, on to SolarWinds. So this was discovered in late last year, late December of 2020. Ironically, to me, it was discovered by FireEye, which is themselves a cybersecurity company. You know, so they actually started observing that a couple of the tools that their teams use had made their way outside their network, we'll say, and so they started digging into it and realized that what they had was after they consulted with some other organizations, what they had discovered was a Trojanized version of a product from a company called SolarWinds is the company. I'm sure you're probably familiar with some of this. The product name was Orion. And go ahead and step to the next slide there, Kyle. So, you know, it had an interesting impact. It was determined that every SolarWinds customer was potentially affected by this. So SolarWinds actually pulled all their customer references off their website just to protect the the identity of the people that might have been affected. As the investigation unfolded, it was found that there was only actually 18,000 of the 33,000 organizations that actually were affected, which, you know, is about half, which sounds good until you realize 18,000 is still a heck of a lot. Yeah. But the most noteworthy thing about this is the biggest customer that was affected, both from a publicity, a bad publicity, and probably the size of the customer for SolarWinds, was the US government. A lot of very sensitive DoD and intelligence agency systems were being managed by SolarWinds. So this was the type of attack that in the end we believe was carried out by a nation state. So go ahead into the next slide there, Kyle. So the reason this was such an insidious, from an attacker's perspective, it was almost like an Ocean's 11, beautifully orchestrated in an evil sort of way attack, is because of what Orion does. So Orion is essentially a network management solution, and it's delivered via an agent, and it goes on every piece of hardware in your infrastructure, your servers, your network switches, your firewalls, your storage appliances. Everything can have this Orion agent installed on it. And since it's an agent, just to state the obvious, in case you're curious what that means, it's a piece of software. It has to have a piece of software installed on it. So if I can get into that software and infect it with something that's nefarious, then I can easily have it spread throughout my entire network. And that's exactly what happened here. The bad actors were able to get into the software supply chain of SolarWinds itself pre-signing. So these agents all appeared to be signed digitally by and approved by the signature authority, certificate authority rather. So nobody had any idea anything bad was going on. Interestingly enough, these agents, the code that was stuck into them actually was smart enough to recognize if the machine it was running on had data loss prevention or firewall or any sort of other anomaly detection software on it, and not use that machine to communicate back out to its control server. So these things were well orchestrated and controlled and affected every single machine on the network. So go ahead to the next slide there, Kyle.
Yeah, and something I'll just kind of briefly add before we move on here as well, right? One of the interesting things is Rob already talked about the impact of these different solutions being IT related. And we'll talk about that a little bit more in a couple slides when we get to some common themes. But one of the particularly interesting aspects about SolarWinds is their Orion platform. SolarWinds itself actually recommends turning off antivirus for those different agents. And so, like Rob just mentioned, right, the attackers leverage this very creative custom code for the exploit to detect some of those different endpoint defense tools that might have been in place. But because SolarWinds provided that recommendation for their own just kind of ease of installation and functionality aspects, it created a much more kind of easily accessible attack surface for the nation state. And so again, we'll talk about that a little bit more and how that relates back to kind of CodeCov and Excellion in a minute here, but just wanted to put that out there for everyone.
Sure, good point, Kyle. So again, the organizations that investigated this broke the attack into 3 stages. Obviously the second and third stages rather, where they were actually actively getting installed on the third-party networks and exfiltrating the data. That's the thing that typically gets covered. But I think for our purposes, I wanted to focus more on that first phase where it was actually, a developer. We don't know exactly the details and probably never will, even if we could find them out. But something was happening in a developer, laptop somewhere that was able to get the code injected into the software CI/CD pipeline. And so that it got put into the system and put into the Orion executable, and then it was signed and went out to all the systems. So that's really the thing that we are seeing a lot of our customers start to focus on more, is how are they building their software and how can they really be assured that the software they think they're building and delivering is in fact the software that they think they're building and delivering.
Yeah.
Cool.
Yeah, and like you mentioned, right, there's a lot of different aspects within this attack where it could have been detected, both within SolarWinds or, again, in the other examples that we've talked about, whether it's CodeCov or Excellion, the kind of source of these attacks. There's also the opportunity as a customer to detect through different monitoring controls. We'll talk about that all again in the next couple of minutes here. One of the things that I wanted to call out, Rob mentioned that we might never know the true source of how this SolarWinds attack came about, but one of the kind of interesting hypotheses is that there was a development server for Orion that had a default password of capital S SolarWinds ! And so if you just think about the incredible ramifications of this attack and how it could potentially all boil back down to something as simple as password hygiene, which as a security community, we've been harping on for decades, really, at this point. I mean, if you think about when kind of minimum password lengths and complexity requirements were put in place. And so it's often still some of these simple things that end up tripping up our security industry. All right, so the rise of the supply chain attack, probably many of the folks here on this call weren't really familiar with the idea of supply chain attacks until SolarWinds. This is kind of the biggest one in recent history that has generated so much press just because of the outcome and impact, like Rob mentioned. Again, 18,000 companies, so many federal agencies, and again, massive companies like FireEye and Microsoft that you just don't expect to have these kind of security issues with. But as we take a look at the timeline here, we can see that these extend so much further back than 2020. So it's not a new concept. It's just been kind of reinvigorated with some of these different nation states and a new focus area in terms of how they launch different attacks because of the potential impact. So we won't go through every one of these one by one, but we can see that, again, especially around kind of mid 2017, 2018, these attacks started exploding in frequency. And as we think about just the last year or so now, there have been several more with significantly higher impact. And as you think about the just kind of security industry as a whole, we've seen ransomware create a significant uptick in likelihood or just general use by these attackers as one different type of attack mechanism is proven to have demonstrated results, then other attackers and organized crime groups will follow suit. And so the same way we're seeing this exponential uptick in ransomware, we're seeing similar trends in the supply chain attacks. So again, like I promised, what are some of the common themes thinking back through these different attacks? Well, first of all, like Rob mentioned, for the SolarWinds attack, they were extremely sophisticated. This ties back to the nation state attackers. We're seeing more and more, if we think about Colonial Pipeline, for example, SolarWinds, Excellion, CodeCov, all of these are, again, at least presumed to be executed by nation state attackers. The resources of these different organized groups just far exceed, in most scenarios, the ability for different defense organizations to actually detect and prevent these attacks. And so that goes back to the idea of assumption of breach, which so many organizations are operating under today, where they recognize that ultimately we might just be outgunned compared to some of these sophisticated groups, and it's our job to try to limit the impact as much as possible. And so, again, we'll continue to see these kind of advanced attacks moving forward as more and more groups recognize the financial incentives and reconnaissance incentives that they're able to gain. Again, we think about the federal organizations that were targeted through these supply chain attacks. Those might have been the kind of primary goal of a supply chain attack, and everyone else who's a customer of that tool might just end up being collateral damage. But because of the kind of extensive reach of all these business-to-business platforms today, which ties into our next point here, then there's several organizations that might otherwise not be specifically targeted for a cyber attack that then have their own kind of attack surface expanded. So again, just thinking through that kind of targeting structure, maybe the easiest way into one of these federal organizations, rather than trying to attack kind of the front door or specific service, is going through one of their software suppliers. And that's what we're seeing with some of these supply chain attacks, and I'd imagine we'll continue to see moving forward until these different business-to-business applications improve some of their security controls, and until the defenders and the purchasers adjust their controls accordingly. And again, we'll talk about what some of those controls actually look like in the next couple of minutes here. Now, the next piece, which again, we already alluded to when we talked about SolarWinds and the kind of IT related aspect, how it's tied into so many different aspects of an IT organization. Well, again, the same thing applies for both CodeCov and Excellion. In CodeCov's case, it was specifically tied into development environments where they're able to then grab some of these different secrets and credentials and then apply those across an organization. For the Excellion case, because it's a file transfer system, it has direct access to different sensitive files that the attackers were able to leverage. So because these platforms are IT related, you would, one, expect that there would be kind of higher security controls in place and a higher standard in terms of how these different tools are developed and maintained. But at the same time, it's a much more kind of luring target for attackers because of the potential impact and the easier lateral movement in the customer organizations when those tools are compromised. Now, finally, the last piece here is length of attack. So we talked about the timeline for Excellion. Again, 6 months after the breach was originally disclosed, we see more information coming out. Well, even before that, especially if we look at attacks like SolarWinds, the initial compromise was made back in 2019, and it wasn't disclosed until December of 2020. So it was over a year that the attackers had initially accessed that SolarWinds environment, and it was several months that they had access to the different customer environments before it was disclosed. And this ties back to point number one here around attacker sophistication, where they recognize that in order to succeed in some of these different attacks, they might need to be patient, but they have the resources in order to do so. And so it makes our task as defenders insurmountably kind of more difficult just due to those resources that are being expended there. Now, what are some of the key significant differences to talk about? It's worth keeping in mind that industries are not necessarily specific. So in terms of the customers that are actually purchasing these different tools, right? Something like SolarWinds impacts customers across a wide variety of industries. We talked about government organizations. We talked about big tech companies like Microsoft, but also energy companies. It could be healthcare companies. Any tool or any company that's using IT solutions is then applicable for these. And so if you think to yourself, oh, well, I work in a niche industry, so I don't have to worry about supply chain attacks. Unfortunately, that's not quite the case because so many of these tools have customers across a wide variety of industries. Now, the next piece here, and we already talked about this, but the exact initial exploitation mechanism, like Rob said, for SolarWinds, we might never know. We have some hypotheses that are in place, but for CodeCov, Excellion, and even SolarWinds as well, it's not the exact same initial vulnerability. It's the ability to impact that application source code and packaging, which is then communicated out to all these different customers, that really defines the supply chain attack, rather than a specific 0 day in a development server or whatever it might be. So it's worth keeping in mind, right, that there could be a wide variety of different application security issues that could lead to one of these supply chain attacks. And it's not as simple as just, hey, update to the latest software version in your Jenkins or CodeCov environment. All right. So let's dive into poll question number one here. Again, answer 3 of the 4 in order to be eligible for CPEs. Really the key takeaway as we think about this poll question here, pretty much everyone is at the risk of a supply chain attack, unfortunately, right? Most organizations today, or I should say many organizations, are building business-to-business software, and a vast variety more are using some sort of business-to-business application in their own operations. Now, if you're building the application, then you have your own concerns to worry about, as you could potentially impact all of your downstream customers. But the other thing to keep in mind, right, is if you're using any business-to-business application within your environment, then you're exposing yourself to the risk of that organization and their threat landscape in some capacity. So again, we'll touch on that in a bit more detail in terms of how you can actually go ahead and help manage that. So 22% do not sell business-to-business or third-party, do not sell business-to-business applications or use third-party software. That surprises me, but clearly in the minority there. And again, we see a very high percentage of individuals or organizations here are actually using business-to-business applications from others, again, increasing their threat landscape and extending it out to that organization. All right. So hopping to the next slide here, what are some DevSecOps lessons from this whole, these variety of events, I should say? We'll touch on a few different pieces, and we'll specifically dive into the kind of application secrets management piece in a good bit more detail. When we think about this first slide here, this is thinking about the actual source organizations. So we're not talking about a customer of SolarWinds like Microsoft. We're talking about SolarWinds itself. What can they potentially do to reduce the risk of a vulnerability in their application that's then transferred down to their downstream consumers? The first one, the most straightforward, is security testing. So understanding if you have vulnerabilities in your application, that could potentially present issues with the variety of different customers depending on the application landscape. So what sort of testing processes and tools are being put in place to identify those application vulnerabilities? There's so many different testing suites that exist today. We have static, dynamic, software composition, interactive. And a lot of organizations are struggling to say, okay, well, I might have static and dynamic. Do I need these other two? How can I address the appropriate level of security risk in my applications without just buying every single tool that hits the market? Well, unfortunately, that is a very unique and difficult decision for your organization to make. A lot of these different tools address different categories and types of application risk. So it makes sense to kind of leverage as many of those as you possibly can, depending on your organization's risk appetite, because any vulnerability could present a significant level of impact. And one thing that I'll say just on the kind of software composition analysis piece, it extends back to this greater theme of supply chain attacks. Right? Software composition analysis, for those who aren't familiar, basically scans the different third-party libraries that your application team is leveraging for software development and identifies if there are vulnerabilities in those third-party packages. So, for example, if you're using a jQuery library, that jQuery library might have security vulnerabilities in it that pose a risk to your application. Now, again, just tying back this whole theme, that's very similar to the supply chain model that we've talked about here. A jQuery vulnerability then extends down to all of its downstream users and customers. The same way, a vulnerability in the SolarWinds application then extends out to all of its customers. So that's just something to keep in mind. And again, a lot of different security testing processes and tools to put in place. Now, the next piece is specifically related to the kind of code development itself. So implementing features or processes such as commit reviews. Apologies for a second there. Implementing different processes and capabilities such as commit reviews. So making sure when a developer makes a change, there's another pair of eyes that's able to go ahead and look at that commit in order to verify the changes that are made, both from a security aspect, a functionality aspect, and just a general integrity aspect, right? If you think about, for example, a malicious user or malicious attacker is able to exploit the code environment and release a new software version, maybe it's just a very minor change, but if there's a culture of commit reviews in the organization, then ideally someone would recognize and say, hey, this commit was added to the environment, but there wasn't actually a review done for it, or no one kind of remembers seeing those changes. That's something worth investigating in a bit more detail. So even if your security testing tool doesn't actually catch the changes, you're able to identify these kind of anomalies and then make more informed security decisions from there. Now, the next piece is CI/CD pipeline access. CI/CD pipelines are becoming more and more common as we think about just kind of modern development best practices, enabling so much automation and just rapidly improving the speed of software development and delivery. But at the same time, it introduces a new threat surface. If an attacker is able to exploit a CI/CD pipeline, then they're able to potentially threaten the integrity of the software that's pushed through that pipeline. And so it becomes increasingly important to install kind of best practices or implement best practices around the CI/CD pipeline from a security best practices standpoint, such as access mechanisms. And then finally, we have CI/CD orchestrators. So similar theme within these CI/CD pipelines, there's a variety of different tools and scripts that might be leveraged. It's important to kind of monitor the different aspects that are being used, make sure that they're all legitimate business cases as they tie into the development process, and that they're monitored again for any sort of anomalies that might suggest security issues. So let me pause for a second there. Rob, anything in particular you want to add? There's obviously so many application protections to put in place. We're just kind of touching on that development aspect here, but what are your thoughts?
Yeah, I would agree, especially on that last point about the orchestrators. There's just so much in a modern, not only a development environment, but really a modern company, but specifically in a development environment that is gotten automated. It used to be done by a person. The person had a login, and so we knew who did what, and we could put the traditional identity controls around that person and what they could do. But now that things are automated, sometimes we tend to forget that these jobs get kicked off and they go off and do things that a privileged access person would have done in the past, and now they're being done by just any old automation out there. And maybe those automations get started by people who shouldn't be starting them.
Yep. Yep, it's a great point. And again, there are so many other just different application security controls that can be implemented.
Mhm.
We're not touching on all of them here. Threat modeling is a great one that I always end up talking about. And so this unfortunately isn't an exhaustive list, but it's at least a way to keep in mind some of the kind of key issues that might occur around the integrity of a software development pipeline and a software development version in particular. All right, poll question number 2. And this is related to the different types of application security controls that you are currently leveraging in your organization. We'll give just a minute here for folks to go ahead and answer. As we think about options 3 and 4, the idea is to basically delineate between security integrations in the CI/CD pipeline. So, for example, a SAST tool automatically kicked off as the CI/CD pipeline progresses, versus option number 4, which is the controls of the pipeline itself, which we just talked about on the previous slide, right? So something like monitoring the significant changes to like a YAML file that defines a pipeline. All right. Let's go ahead and close it up here if we have enough answers in. All right, and we can see, as I would kind of expect, application security testing tools are becoming increasingly common. Again, a lot of folks today recognize that for fairly little setup and little effort from your internal team, you can implement a tool such as static application security testing and have a better understanding of the vulnerabilities in your source code. We see 10% or rather 15% have application secrets management. And then we can see kind of the last one that I was just talking about there, right? The CI/CD pipeline security controls, those are largely lacking. And that's totally understandable. I mean, I'm sure all of us can recognize different internal applications that might not have the kind of best security standpoint. Oftentimes, security gets more focused on the external applications that are put out by a company rather than some of those internal, just kind of operational tools. And so CI/CD pipelines often kind of get left at the wayside in terms of the corresponding security controls. So clearly an opportunity for improvement as we move forward as an industry. All right. So the next one here is talking about security monitoring. So we just talked about the actual application development standpoint, and that's again as the kind of source organization of one of these supply chain attacks. We want to briefly touch on what it takes as a customer of one of these different applications, what is really needed moving forward in order to address some of these new attack vectors and some of these very sophisticated nation states that are leveraging these supply chain mechanisms. So first of all, anomaly detection. In the past, as you think about your security monitoring team today, it's probably largely focused on explicitly malicious activity, right? And so there's different rules that are built out within your SIM, your security incident event management platform. And that's looking for signals that say, okay, this is malicious. Here's an FTP transfer, for example, to an external host. Here's an IP address logging in from Russia at 2 a.m. in the morning, different activities like that. Well, anomaly detection says we might need to go beyond the explicitly insecure. As we think about some of these nation state attacks and the SolarWinds example in particular, there were not that many explicitly malicious steps. There were a lot of aspects that should have maybe raised some eyebrows if you're looking for them appropriately. But it was very difficult for traditional security monitoring teams to go ahead and detect this, again, as evidenced by this attack breaching some of those leading security companies like FireEye. And so moving forward, it becomes important to say, interesting, these certificates haven't been used in this way before in the organization. It might not be explicitly malicious, but it's something at least worth noting and kind of processing through the greater data analysis capabilities of the organization. Then when that activity can be correlated with some other anomalies further downstream, such as that certificate being used to transfer data or access new types of data, then all of a sudden these incident response and monitoring folks are able to piece together what the attack looks like, which is previously impossible if you're just looking for something explicitly malicious in one of those individual areas. And so this is a massive challenge as we think about security monitoring issues that already exist today. The amount of data already ingested into security mode programs is just absolutely astronomical. And now I'm asking for anomalies on top of just malicious events. It's a big ask. It requires extensive data analytics and data science capabilities, but it is the future in order to detect these more advanced attacks. Now, the next piece here is workforce development. So as we think about that same kind of trend that I just talked about, it requires training and the curiosity and attentiveness of the different individuals in the security monitoring team to think about attacks in that manner. And so in addition to the tools looking for that kind of new activity, the individuals need to look for that as well. Data science and data analytics is incredible, but at the same time, humans have the right investigative capabilities to kind of piece together those different aspects. And so as you think about what you need for your security monitoring team moving forward, well, it's making them aware of the potential impact of supply chain attacks, what they need to be looking for as a customer of these different tools, and how they can kind of adapt their approach accordingly. Now, the last piece may be a new idea here for some folks, but the idea is basically intelligence sharing. So there's plenty of third-party threat intelligence platforms that exist today. Organizations can go ahead and pull down threat feeds from different companies like MISP or the NVD, but at the same time, that's all very specified around explicitly vulnerable activity. Whereas instead, the future of intelligence sharing might look more like anomaly sharing, which can then be pieced together over a greater landscape of different companies to identify malicious activity. So rather than saying, hey, I've been breached, here's this intelligence, everyone else take a look at it, it's getting to the next level and saying, hey, I noticed this weird certificate activity, just want to let everybody else know. If you see all of a sudden there's a couple other major companies that are noticing a similar anomaly, well, then all of a sudden you have a much higher likelihood that that's related to something malicious as opposed to just some user in your organization behaving strangely. And so again, recognize that these are advanced capabilities, and this is a bit more of a kind of futuristic look, but it's important to keep this in mind as you think about your supply chain protections.
Yeah, the workforce comment there, I think, is particularly important. Excuse me for jumping in there, Kyle. Yeah, because you mentioned, humans have to apply the curiosity, and you kind of have to think like the bad guy and ask yourself, well, if I were trying to break into my company, what would I do to get through the door? But it also, we'll talk about it a little more later on, it actually extends, up the chain into the development. What are my developers using? I wonder what they're using to do the testing. I wonder what other things they're downloading off the internet from freeware and open source websites that they might be using to build code. And are those things safe? Just there's the more questions you ask, and again, not in an accusatory way, obviously, but just in a, hey, we need to make sure this is secure sort of way. That's a key aspect to getting the sec and DevSecOps.
Yeah, that's an incredible point. I mean, tying back to the whole philosophy of DevSecOps, right? It's really having these different teams work together with one another, better understand each other's processes. And that directly ties into what Rob was just saying, where as a security team, if you understand the tools and the constant or normal activity that's occurring in your organization and these other teams, then you're going to be able to make a better designation in terms of what's actually malicious. All right. Poll question number 3. This is similar theme to the last one that we just had. What sort of monitoring controls are you actually applying within your organization today? And SOAR platforms, for those who aren't familiar, security orchestration, automation, and response. The idea is SOAR platforms are generally, I like to say, one of the key kind of applications of DevOps within security. So leveraging the same kind of themes of orchestration, automation to actually help security do their job better with the monitoring and response program. And so that's just another good example of how DevOps can be applied within security, as opposed to just the kind of traditional idea of security integrating itself within DevOps. All right. We can see advanced security monitoring rules and alerting, again, kind of similar to what I would expect here. One of the things that is kind of occurring to me here, I imagine it's just a choose one based on the responses that we're seeing here. So maybe there are folks here that are using multiple of these different options, but at least thank you for kind of playing along with us. So one of the things I am surprised to see is kind of the very minimal usage of SOAR platforms. So only one respondent is actually using those platforms. These are becoming increasingly common, but it's a significant investment to both procure the tool initially and manage and maintain it moving forward. And as we think about some of the different aspects that we just talked about, right, it requires an intense level of kind of data analysis and overall organizational understanding. And so these SOAR platforms certainly do help with that overarching initiative. All right. So what are some of the lessons learned from this whole event here? Rob, you want to go ahead and take a stab?
Sure. I'll take a few of these and chat through them, and then we'll swap off. So number one, I'll talk to that one. Identity management is still at the core of everything. I mean, it all begins with something or somebody getting an elevated level of privilege that they shouldn't have, and then it all goes downhill from there. So I assume that most people on this call probably know that and have heard that before. You probably are using the CyberArk tool suite to manage that, but that's that's just kind of stating the obvious. Kind of jumping ahead a little bit to number three, multi-factor authentication is also pretty much a no-brainer at this point. I mean, if you're not doing that, then you really got to ask yourself why. Kind of going across over to number six and talking about that one here in a little bit. So might need a bingo card here to keep up with which ones we've done. The developers, and again, I used to be a developer. I know how developers are. We like to download stuff. We like to try cool new things. We claim we need laptops with no security controls on them because you're hampering our creativity. But really, anybody who's been to a Starbucks and seen somebody over in the corner writing code connected up to the Starbucks public Wi-Fi and doing saves into GitHub, it doesn't take a genius to realize that that's a recipe for something very interesting to happen, I'll say. So they really need endpoint protection and security controls. Granted, they might be at a different level than other people in the organization, but you cannot just let them throw everything out the window. Kind of jumping back over to number two, I'll talk about that one for a second. We'll talk about it in a little more detail in a few slides coming up here. But really, the identity MFA developers, those are all people. But so much of what we talked about for these breaches that happened earlier, they were enabled by secrets, things that weren't people, a password for a system or a token to get into something or a private key that got put out in the public. Something happened that shouldn't have been allowed to escape, got out. A secret, in other words, was made known. So you really, and again, on the polling questions, I noticed on the second one, there was only 10% of the people, I think, using any kind of secrets management solution. I'm hoping that, again, that was just because of the fact you could only pick one, but it's got to be more than 10%. I'm sure it's not 100, but I would encourage you, definitely, you've got to have something out there to manage the credentials and things your applications need to do their jobs, because it is definitely they're out there doing things just like people would have done them a few years ago. So you can't just let it all be a free for all. And then jumping down kind of to the fourth one there, DevSecOps is more than tooling. Back in the days when it was just DevOps before anything got inserted into the middle now. And I think there's a whole myriad of other three-letter acronyms that are getting inserted in there nowadays. But really, DevOps was a way to bring developers and operations together. But at the end of everything, it was a cultural shift. Developers, I was a developer, I've said it before, developers hated operations, but all the hard work was writing the code. Once we write the code, we give it to operations. All they got to do is go run it. And why do they have to go break it? And operations hated developers because developers kept wanting to change things and break the systems. So I think we've overcome that belief with bringing developers and operations together. But now the next wall we need to tear down is the belief that security just says no to everything, and that we have to keep them out until the very end, because otherwise they won't let us do anything. And again, that's a cultural shift. There's a reason why developers want to change and why operations don't want change, or there's a reason why security sometimes has to say no. And I think once everybody realizes that and realizes why they don't always have to say no, then everybody will get along better. But it's not, you don't go buy a tool to put the second DevSecOps. It's got tools in it, but it's a people problem as well.
Yeah. Yeah, and then one more thing that I'll just touch on there, right, is as we talk about multi-factor authentication, one of the interesting aspects of the SolarWinds attack is the way it was finally identified that year and few months after the origin of it, is a FireEye employee got a multi-factor authentication prompt that they weren't expecting, saying that someone was trying to log into their account, right? And so FireEye, again, leading security company, so many different security controls and advanced techniques, but what tipped them off and allowed them to do their comprehensive investigation and allowed them to ultimately expose this entire attack was just a simple multi-factor authentication prompt and a user that knew the right policy to go ahead and reach out to their security team when they saw that anomaly. All right, next steps, just briefly cover this. What have we talked about today, and what does that actually lead into? Well, first of all, you need to go ahead and assess the risk to your organization. So of the different controls that we've talked about today, what do you have in place? What are you missing? And what is the impact if these gaps remain? Again, the impact to a company that's actually developing one of these business-to-business applications is different than an organization that is a customer of these different tools. But at the same time, depending on your organization's industry, different regulation that you have to comply with, you're at risk of either potential fines, brand impact, et cetera. So it's understanding, okay, what's the acceptable level of risk to our organization? And then what's the plan to actually go ahead and remediate this? And this plan needs to obviously be in context of different business restrictions that you have and constraints, such as your financing, the funding for your team. What is the order that we want to approach this in that resolves as much risk as possible the fastest? And then who on our team is actually going to lead these different initiatives? Things like these advanced DevSecOps and security operations initiatives can be extremely challenging. I'm sure everyone on this call right now is familiar with the negative unemployment in the security space. It's extremely difficult to get the right people in to handle these different advanced capabilities. And then again, we talked about DevSecOps is not synonymous with tools, but what tools do we need to actually accomplish some of these different objectives? Even though it's not synonymous with tools, there's obviously tools that will help over the course of this transformation. And then finally, it's taking those plans and acting. So with that, let me turn it over to Rob again here, and he'll talk a little bit more about CyberArk, Conjure, and how that ties into some of what we've talked about today.
Sure. So just a few practical thoughts here for us. I guess from the CyberArk perspective, the first thing I'll say is that really security has to own security everywhere. Nobody goes and when there's a breach and looks at it and says, oh, it's because a developer did something. That's okay. Never mind. You own the we own the responsibility. Security people own the responsibility for security. And so we've got to start backing that up in the software development lifecycle. We can't just wait till we get code to run and operate to go worry about it. It's got to go all the way back to the beginning, especially with the DevSecOps culture change we've talked about so much earlier. Let's go to the next slide, Kyle. So the result of doing that is if we start to worry more about security, we can offload that off of the developers, because it's kind of one of those things. Somebody is going to do it, just a matter of who. The developers work with dozens of tools daily. They work with a lot of different environments: AWS, Azure, Google Cloud, their own homegrown data center, and they're building applications in some pretty sophisticated things like OpenShift and Kubernetes. All of these things have a place to write down a password to be used to go do something somewhere else. And the global policy should not be determined by the developers making those decisions, because at the end of it all, none of these are really enterprise grade security systems. That's the thing that the security team needs to make the decisions on. We don't want to have islands of security. We don't want to have something delivered into our operational environment that has some other type of place to store passwords that we're not aware of, where we're not going to rotate them, where we're not going to be able to change them on demand if needed and things like that. So we make the security decisions, the developers do the developing, and everybody stays happy. Going to the next slide there, Kyle. Really what we're talking about here is owning the entire chain of trust. So in the blue line there, kind of in the middle, the people on the top there, the humans, that's who you probably traditionally think of when you think of CyberArk and us, making sure that everything stays safe there. But below that line is where Conjure comes in. So we can take not only the people and make sure that we know who's doing it and that they're authorized to do it, but if they kick off a process that goes off and builds something, we can make sure that the build process is done correctly, that if it's not kicked off by an authorized person, that it doesn't actually go do anything in our system. And then when the code finally gets out into production, oftentimes, any type of code we write that goes and does anything useful for us, it's got to have some level of privilege to do something. I mean, if it doesn't have to log in to something to do something else, then it's probably not very useful for us. Well, that login information needs to be treated as a secret and not allowed to be exposed. So the applications we write, along with the tools we use to create those applications, all have to be secured. And that's where Conjure comes into play. It allows us to have one central vault mechanism to control everything and manage everything. And that way we don't have to have the proliferation of vaults as before. So going to the next slide there, Kyle. And so CyberArk is really the only security vendor that's able to play across not only the human aspect, but also into DevOps and even down into containers. So if nobody's come to you and asked you about container security at your company, it's just because they haven't thought about it yet, because I'll guarantee somebody there is using a container, using Docker or Kubernetes or OpenShift somewhere, and they just haven't come and asked you about it. But it's one platform, highly secure, highly available, strong, innovative, and it's an enterprise-grade solution.
Perfect. So the piece I'll add too, right, is we've talked a lot about the importance of access over the course of this conversation. And again, I think that's largely a no-brainer for a lot of the people in the security field on this call. Well, as we think about the kind of future of security and the future of software development, or even really just the evolution of it over the last handful of years here, automation has become such a key aspect, and each of those different automation components has its own access piece. So we've learned about the importance of human access and securing those passwords and credentials. The idea here behind these secrets management platforms is just recognizing that, okay, our applications have these credentials now as well. That landscape is constantly growing. We need a way to manage this. And Conjure is a very kind of simple, easy to use mechanism that integrates with the rest of your application security tool suite to accomplish that. So finally, last thing, shameless plug on how we can help you as well. I mean, again, we talked about that next steps process of risk assessment, identifying the controls that you need to go ahead and put in place, and then actually going ahead and acting on those controls and implementing them within your organization. Well, we're more than happy to help. If you're just kind of confused on where to get started for your organization, or if you have an idea but you don't have the right folks who can go ahead and accomplish it just because of so many competing priorities, again, such a common problem I hear time and time again from all of our different clients, then we're more than happy to come up with a flexible delivery solution that works for you. We've been able to compress our different DevSecOps assessments exponentially just based on our experience at this point, so we can do it at a very affordable price point for you. And again, we have the technical skills to actually help with the build out and integration from there as well. So finally, last poll question, and then we'll let everyone go. Casey, if you could go ahead and maybe drop Rob and I's emails in the chat so people can go ahead and reach out, or you can find us on LinkedIn. Again, more than happy if you just want to have a conversation, no strings attached, just to discuss the different approaches that you're following within your DevSecOps program, or what you can do to further secure your organization and what some of those next steps might be. We're more than happy to help. So please don't hesitate.
Absolutely.
All right, let's wrap up this poll here. and we can see there's a kind of mix across, which is again to be expected. There's so much to be done in this space and such a kind of wide landscape of these supply chain attacks. It's a work in progress for everyone, and it sounds like a lot of people are at least started on that journey. All right. Well, thank you so much again, everyone. We're out of time, so I don't think we're going to be able to take Q&A here. But if you do have questions, again, please just reach out to us, and we'll be happy to answer those for you in a separate channel here. So thank you all again, and hope you have a great rest of your day.
Thanks a lot.